Okay, so let me slowly start, and then I would say hi, everybody. Good morning, good afternoon, and good evening, depending on the time zone. My name is Daniel Szegö, and today I'm just gonna give a talk, basically, a presentation and like a very short demo on a very special topic, which is like tokenized zero-knowledge machine learning and its applications. It's a pretty niche topic, I would say. We're not gonna go very much deep into the details, into the theoretical details. It's just gonna be more like a high-level talk for everybody. So perhaps we're gonna have like a subsequent meetup in a couple of months, and then going really deep into the mathematical basis. But this time it's gonna be just high level. Despite I think it's gonna be interesting. Perhaps just a couple of words about myself. I'm a software engineer. I've been dealing with different blockchain applications for several years, and then I would say, I mean, a zero knowledge stack is getting to be more and more interesting as well. I'm not a mathematician, unfortunately, so I'm mostly an engineer. But even for an engineer, this zero knowledge stack with blockchain and already with machine learning getting to be very much interesting. So let me just start. And recently, basically, one of the big question and brainstorming is how we can combine applications based on blockchain and AI. There are several reasons for that. I mean, on the one hand, basically, AI is pretty much in hype. I would say blockchain used to be in hype. Perhaps it's gonna be again in hype. But perhaps again, it's just like fashion questions or hype questions. But there's usually a big brainstorming how we can combine like applications which have like components with blockchain and basically with AI as well. So like blockchain AI convergence. And there are some interesting possibilities for merging these two fields. But so I would say some of these applications are not very, I mean, not very brilliant. So there are just like a couple of good ideas, like using AI for blockchain data analysis. That's of course that's one possibility. Then you can use, for instance, AI for transaction graph analysis, for instance, like for de-anonymizing basically transactions. But somehow that's an interesting blockchain and AI application, or blockchain and machine learning application. But somehow it's not really the decentralized artificial intelligence or decentralized machine learning that you would expect, basically. And then, of course, there's like initiative for crypto asset price prediction. Again, like de-anonymizing like user transactions. That's my next one. But basically, again, it's like not somehow the application that you would expect from a blockchain. If we say blockchain, we would expect somehow trustless applications, even if they use like AI components as well. There are initiatives like for using AI services with decentralized marketplaces, and that's like more interesting and more has the characteristic of having like really decentralized AI applications or machine learning applications. One famous example is like the Singularity Net. It's like a marketplace with different AI services, I would say. There were some initiatives for real decentralized machine learning algorithms as well with the help of blockchain. That was like one is Neural, but they just didn't manage to have a breakthrough basically. So that's like kind of a direction of having AI or machine learning in a decentralized application fashion. But again, there are just not many such initiatives. And then there are sometimes like using AI and blockchain in a sense that you just use blockchain for tokenized intellectual property or intellectual property. So if you just generate data with the AI, then you can somehow make an IP claim for that and just somehow register in the blockchain. But again, so these are certain initiatives. Somehow they just, if you're long in the blockchain field, you would expect something which is like a nice decentralized AI application, and then most of these initiatives are not that basically. So let we have like another more focused slide, or more focused area, which is, I would say, trustless machine learning on-chain. So if we don't cover just AI, but like a more focused area, which is like machine learning, then we can ask the questions, what are the possibilities of bringing machine learning on-chain? And unfortunately, there are not many possibilities executing machine learning directly on-chain. It's because of the scalability issues. So if you think of blockchain, the problem is they are still slow and still cover relative. I mean, not enough computational power, I would say. They just struggle, for instance, having like the necessary transactions per second and so on and so forth. And some of the machine learning models require computational power, of course, both for the training, I mean, especially for the training, but usually for the inference task as well. So it's just pretty difficult to bring like a neural network on chain and execute that neural network on chain with like smart contract in a real decentralized manner. So like the direction is like having on-chain machine learning is tricky, is difficult. And perhaps, I mean, it might happen that like in a few years, there will be like applications, layer one blockchain applications that really manage to execute machine learning algorithms on-chain. But as far as I know, until this point, this is complicated. So another way is kind of, if you want to combine machine learning and blockchain, simply importing machine learning results on chain somehow in a trustless way. So we would expect like more or less the same trustless guarantees for the imported machine learning results that we have on a blockchain, basically. So it's not necessarily decentralized, but if it has like the same trustless guarantees, then we might as well regard that basically the whole architecture has the same trustless, same decentralized guarantees. And if we think of that areas, there are many application areas. It's like, just imagine a couple of like privacy preserving credit scores for lending protocols. So if you think of like DeFi, a lot of DeFi protocol might require like zero knowledge machine learning protocols or machine learning oracles, basically importing machine learning results on chain. But as far as I know, like 99% of the DeFi protocols not having this functionality at the moment. It's because pretty much in research and development. But for instance, like imagine a decentralized lending protocol or even perhaps a semi-centralized DeFi protocol on chain. If you need like a credit score, which is like imported basically with the help of an external oracle, and it has some machine learning components, it is difficult to import in a trustless way. You can think of like having like KYC processes that has some machine learning component, and then the result should be imported somehow in a trustless manner. Now you can think of like improved stablecoin protocols. I mean, especially at like predicting the stablecoin rates that would require some new algorithms, and then these algorithms can be like supported by machine learning protocols. But for that, of course, we should just somehow import the result of machine learning in a trustless manner. And of course, so the way I see most of the areas is like improved DeFi use cases. Like one example is if you think of like AMM, like in matching algorithms or in trading algorithms, then there can be like a more intelligent pricing algorithm, for instance. Then we can think of like private machine learning models with tokenized IP, intellectual property protection. We can think of like, I mean, it's trading. I don't especially like trading in a sense that it's not like a very fancy blockchain application. Of course, it can bring a lot of money. But there are some initiatives like tokenizing trading bots, for instance. And then the problem is that, I mean, in most cases, you can't really verify what the trading bot does, how effective it is. There's just some claim that your trading bot or the trading bot should bring like money or should generate profit, but there's no proof for that. So with the help of like a trustless machine learning, you could bring like kind of a verification for your trading bot. You have a trading bot which is like based on machine learning, and then if you bring that machine learning on chain in an on-chain verifiable manner, then you could have the proof basically that your trading bot really generates profit, and then there's no other kind of fancy business model behind the protocol. So that's basically I started in a reverse order, and then I didn't start with like tokenized zero knowledge machine learning, but basically I started the application possibilities or application areas. So I'm just gonna continue, and then I have a couple of slides on zero knowledge. So again, I mean, the idea is of course certainly nice that we should have like on-chain machine learning, but again, the problem is it's just difficult. So the question is how we can bring like off-chain machine learning models on-chain in a trustless way. And for that, we need the zero knowledge stack. So I'm just gonna have a couple of slides first on the zero knowledge stack as well. I'm not gonna have any mass, but if you're not familiar, so basically zero knowledge proof is kind of a proof, not necessarily in a classical mathematics sense, more like it has some different definitions as well, but it is a proof of a statement, for instance, and then basically usually if we imagine like zero knowledge proofs, we have like two roles. We got Alice and we got Bob, and then Alice wants to prove something for Bob in a way that Bob will be sure that Alice really knows a kind of fact in a way that Bob doesn't know that fact. So for instance, one example is like this Sudoku. So for instance, Alice might try to convince Bob that she knows the result of this Sudoku or the solution of this Sudoku puzzle in a way that Bob is convinced that Alice really knows the result of that Sudoku puzzle, but Bob will not know basically the solution himself. So that's actually the idea for zero knowledge proofs. So it's not necessarily a very classical mathematical proof. It is sometimes stochastic, so not basically a proof with 100%, but like 99.999%. It's just a proof with sometimes just a proof with high probability. Sometimes it's kind of a game. So basically, or not game, but kind of a communication, I would say. So it's not necessary. It can be interactive and non-interactive. If it's interactive, that there are like many messages that are exchanged between Alice and Bob. And at the end of this couple of messages, basically Bob will be sure that Alice knows some kind of a secret, but Bob will not know the secret itself. Okay, so basically we had like these two roles, Alice and Bob. We can say as prover, as verifier as well. And we get like stochastic and or probabilistic and non-probabilistic zero knowledge proofs, and the interactive and non-interactive. And the field is pretty huge, I would say. One of the area that is pretty well investigated is like SNARK or zkSNARK. SNARK is basically a succinct non-interactive argument of knowledge, and it can be zero knowledge as well. Succinct means short, it's a brief proof. Non-interactive means that basically there's no interaction between Alice and Bob, between the prover and the verifier. Alice can prove this statement like in one iteration, basically. It's certainly the best way if we do anything with blockchain, because in blockchain applications usually there's no way of having much interaction. So basically we just prefer non-interactive proofs. Argumentative of knowledge is like kind of a fancy way of saying that we want to prove that Alice knows something, that the prover knows something. And it's important that it can be zero knowledge as well. It's not necessarily zero knowledge. Zero knowledge means that the validator Bob will not know anything about the fact, about the statement itself. So basically, what we have is like a function that's like a computational function, which is like evaluated to true or false, and it has some inputs basically. So it's a very simple high-level model, and we can have some public input and private inputs as well. And the idea is that basically this function is implemented somehow, usually in a tricky way with like arithmetic circuits and rank one constraints and other mathematical magic. But the idea is that basically this function will be evaluated like for true or false, and then basically we can be sure that there are some inputs for which this function evaluates true or false, and if there are private inputs, then basically the proof works in a way that the verifier will not know these private inputs. It's important to point out that I mean, of course, in machine learning, what we're gonna do, we will have like a machine learning model instead of this function. So that's gonna be like a I don't know, convolutional neural network basically for a person, or kind of a backpropagation learning with neural network. That's gonna be the function. And it's important to point out that we can have like public and private inputs as well. If you have private inputs, that's really a zero knowledge proof system. But we do not necessarily want to have like private inputs. It makes sense just to have public inputs, because it looks that way that there's a characteristic which is called succinct. That means that the proof is short. Basically, it's brief. It's just shorter than the whole model, or than executing the whole model. So even if we have like just public inputs, we can imagine application for that. Like we have like a complex machine learning algorithm here, which is evaluated to something. And then basically it looks that way. We just use public input, but despite we can just verify the result on chain, and this result and this verification will be basically fast, and it doesn't need to run the whole machine learning model basically on chain. So again, we can imagine like both Snark and zk Snark. Practically, so this is like a deep mathematical topic, but practically what we usually have is like a zk programming from an engineering perspective. So I'm as an engineer or as a software developer, not gonna start directly, like having algebra and then making making real deep math for the first run. But we have a couple of like frameworks, and these frameworks really set up basically zero knowledge in a kind of an engineering flow. So that usually looks that way, that we have like a special program, which is like sometimes a domain specific program for Snark. So it's really for zero knowledge programming. Sometimes it's domain specific, sometimes it is like part of a bigger system like a Rust library or something. But there are a couple of examples like Circum, Socrates, Noir, and so on and so forth. And then as a developer, we just create our high-level model in this, let me say, that domain-specific language or domain-specific program. And there's a compiler that somehow compiles this more or less high-level language to a more zero-knowledge friendly format, which can be like rank one constraints, for instance, or arithmetic circuits, or some kind of a magic. And the framework helps as well generating basically proofs, and then just distributing like keys for proving and for verifying different parameters. So basically, as a developer, I mean, of course, it's always better if you understand, or if one understands basically the deep math behind, but it's not necessarily a must. There can be something done from a more engineering, from a more developer point of view. So that's basically the idea of zero-knowledge programming. And then, so let me just take a look how we can combine these elements and how can we set up something which is a real zero knowledge machine learning. So again, the idea is basically this one. So what we have here is kind of a computation, and then this computation can be formalized in like a high-level domain-specific language for zero knowledge programming, and it evaluates for the first run true or false, but it can have some outputs as well, basically. So what we want to have is that we want to combine basically a machine learning algorithm with this zero knowledge stack. And then if we think of like machine learning, there are like two phases. So it's just more complicated in a sense, because for first round, machine learning can have like two phases. One is the training, and the second one is kind of a trained model. So if you have an already trained model, then it can have like an inference phase. Sometimes you can mix together these two phases, and of course in training there are like supervised and non-supervised learning and a lot of deep thing. But for the first run, let me just assume that we assume just these two phases that might be even separated. So we have a learning phase, and then we have an inference. In learning phase, we got some data, and with the help of this data, we just train our, for instance, neural network model. And in the inference phase, we already have a trained model, and basically what we do is like an input-output association based on the trained model. So that's the idea behind the whole thing. And then, so let me just take a look how we can combine machine learning and zk-SNARK, for instance, or zero knowledge proofs. So for the first one, most of the initiatives are working on the inference phase. So we usually assume that there's a trained model already, and then we work with this trained model. And then we want to bring somehow a result of a trained model on chain with the help of a zero knowledge proof in a trustless way. So that's basically the idea. So basically we have a trained model, and we have an inference phase which is supported by zero knowledge proofs. Perhaps I would just point out that, I mean, of course, the training is more computational, resource intensive, but usually the inference phases requires some heavy computation as well if you consider the capabilities of a layer one blockchain. Okay, so I mean, even if we speak of just the inference phase, it makes sense that even the inference phase is executed off-chain, and then the result is brought somehow on-chain in a trustless manner. So basically, we speak of usually the inference phase, and this inference phase is executed off-chain, and it is there's somehow a zero knowledge proof which is added to the result, and these proofs and the result of the computation can be validated on-chain, and this validation will be really decentralized. So practically, it gives like a guarantees, the same trustless guarantees for the whole architecture. Then, I mean, similarly as the whole inference would have been executed on-chain. And then we can combine zk models. We just gonna take a look on a couple of like zero knowledge and machine learning models. Even if we speak of like inference, so we can have like inputs, outputs. We can have like trained models, and for both the, I mean, for the input and for the output and for the trained model, we can imagine that certain parameters are public or private. So if you just think of, again, this computational structure, we can imagine that we have inputs and only public inputs. So we can imagine that everything is input, everything is public. And if everything is public, despite, I mean, a SNARK makes sense because the result can be evaluated in a much faster and much more efficient way than executing everything on chain. But we can imagine that certain parts of our machine learning are private, and then we can have our input of our machine learning private, or input, or basically the training set of our trained machine learning as an input parameter. Okay, so that's what we can combine. And before going more into the details, I would just point out that there's another initiative as well, which is something similar. So the idea is bringing basically trustless machine learning results that are executed off-chain, somehow on-chain, but in a trustless manner. But it doesn't use zero knowledge. It uses like an economic incentive, and that's the ML, that's the optimistic machine learning. So again, this is something similar. It just doesn't have like the zero knowledge stack behind, the cryptographic stack behind, and it has some other characteristics as well. So basically, it looks that way. We want to ensure the result, the correctness of a machine learning, but we want to do it with economic incentives practically, not with zero knowledge. So similar, the idea is similar. We just execute somehow the training, the inference off-chain, and the result is imported somehow on-chain. And there's, instead of a zero knowledge proof, there's like an on-chain verification process, which is basically like a verification game. So somehow it works that way, that the result is somehow temporal, so it's not final until it's fully verified, and there can be like several verifiers, and then these verifiers can verify the on-chain result. And if there's like a cheat somehow, or if there's a false result, then the verifier somehow can start the dispute mechanism. And if the dispute mechanism somehow closes really in a way that the result is false, then it will be falsified somehow on-chain. And then basically, if there's no like dispute, or there's no like false verification, then the result will be final basically. So again, it's kind of a verification game. The idea is similar as with like optimistic rollups. So the idea between is the same as zero knowledge or optimistic rollups. Of course, optimistic machine learning has other characteristics. So basically, usually there's like an economic incentive. So if you're a verifier and you somehow disclose a false inference, then you are somehow incentivized by tokens practically that might worth like directly money. Of course, it's just different. The problem is with optimistic rollups is that it has different privacy guarantees. Usually, there can't be like much private input at all, because you should just publish everything to be able to verify. Otherwise, it's just more complicated. It has some performance problems as well. I mean, not really performance, but so if you think of like a verification game, you should just somehow publish the data, and there should be like a time frame in which this published data can be verified and can be judged to be true or false, or good or wrong. And then this time frame might be like a couple of days or a couple of hours. So in this sense, performance of like optimistic machine learning is not exactly the same as like for zk machine learning. Of course, there's another way. There's another direction as well. If you just have to compute like a zero knowledge proof, that's of course that's itself. The computation itself, the calculation of the zero knowledge proof is like computational intensive. That's another aspect. So, having this introduction, let me just take a look on a couple of models. And one model is like zero knowledge machine learning, private input, public model. So in this phase, what we have, like the best idea is just imagine a credit scoring. We got the credit scoring, and then there's some some input for this credit scoring. The credit scoring algorithm is realized by a machine learning model, which can be public. I mean, the parameters of the machine learning model can be public, of the credit scoring can be public, but the input might be like a private input. It's because if you think of, like inputs of a private of a credit scoring model might contain like, how old I am, where I live, how much did I earn last year, and so on and so forth. So these are certainly private informations. But the model itself might be public. That's not an issue. So that's like one setup for zero knowledge machine learning. It's like a private input, public model setup. So again, the inference phase is, this calculation of credit scoring is supported by zero knowledge proofs. We got public parameters. That's the trained model. So the trained model is public. It can be somehow committed to the blockchain as well. It can be made fully public or partially public, but that's basically a public parameter. But the private inputs are basically private, so they shouldn't be published on chain. But there's an output which is like the credit scoring. If I'm, if I have a high credit scoring or a low credit scoring, that's like the output. That the output can be published on chain. The model can be published as well, but the input cannot be published. Okay, so what we need, there must be a proof that the output, which is my credit scoring, is based on a private input and a trained model, and the input must be kept private. So there's an algorithm for that. It's again zero knowledge machine learning, private input, public model. So the first one is just we commit the parameters of the machine learning somehow. We just publish it, for instance. Secondly, there's usually a hash commitment in which we just commit a hash of our private input. It looks that way that it can be published, but there should be like a commitment of my private input before the algorithm. And then as a last step, we just give a snark proof that if we committed the hash of the input data, then this hash x was committed into the ledger, and the output, if we apply the machine learning to x, and then the proof has like these two parameters. One is basically the output, and the other one is that basically the previous commitment was basically true, and then we just apply the machine learning model, which is a public parameter. Okay, so that's like one big setup. Let me just take a look at the second big setup. That's like the private model and public input setup. In this setup, we got basically a machine learning algorithm. It's a trained machine learning algorithm that must be kept secret. It's because if you think of it, might be like an industry standard or intellectual property. So I have a very special machine learning algorithm that I trained, and I'm just not gonna, I just don't want to show for anybody. But what I want to do, I just want to use it basically in a trustless manner with the help of a blockchain. But I don't want anybody to see my secret parameters of my trained machine learning model. So that's the setup. And then what we have here is that there must be a proof that the same model was used for different computations. So it's like kind of a indirect service level agreement for a machine learning model. I just trained somehow this model. Perhaps there's even a result like for verification if that works really well. And if that's then there must be just a proof that in every future usage of this model, I just use the same model practically. Again, it's like a kind of a service level agreement for an off-chain machine learning model, we can say. So what we have here, again, it's like two phases. We commit the parameters. The parameters of the machine learning model, they just can't be published, but there can be a hash commitment, like we just commit a hash of these parameters on chain. And then we just give like a zero knowledge proof, a zk-SNARK proof that the input, which is published, that produces a certain output by applying the machine learning model for which we just committed these hash parameters. And there can be a zk-SNARK proof for that. It's doable. And then if that's the case, practically we just proved that we use the same model for generating our output based on the input. But again, the input and the output are public and the model is private. So there's a second use case. There are some other scenarios as well, which might be interesting, but they are just much less studied, I would say. We can have like private input and private model. In this sense, I mean, both the input should be kept confidential and the model should be kept confidential as well. It's more tricky as far as I know. So there's like compositional zero knowledge and multi-party computation directions where you can use such a thing basically. You can have like a public input, public model use case. Again, that's in this sense, everything is public. It's just verifying basically the result of the model is like, you can imagine that computational intensive. So you just don't want to do it on chain. You just want to run your model off chain, and then you just want to verify. You just want to create a very short proof that can be practically verified very fast, and you just want to make the verification basically on chain. It's the succinctness of the computation. Perhaps I would just mention one more example. So things might be getting more interesting if we have like quantum computers on the future, because there might be the case that you can run like machine learning with quantum computers in a very efficient way. And if that's the case, these things will be more and more important because you just want to make sure that the machine learning that was run basically on a quantum computer, which is practically probably more private than even normal computer. So nobody really sees what's happening here, but you just want to have like a proof that was somehow calculated in a correct way. And then you can have like more scenarios here, because I mean that proof there can be calculated on chain, off chain with classical computers. So there's just more play, There's one last interesting, it's pretty much in a research development phase topic, that's like a proof of training. And there are some good articles. I just linked one articles here. So you might consider that you create a zero knowledge proof in a way that you make a proof that your model was trained with certain data, and it manages certain characteristics of your data. That's again like a research scenario. So far so good. So let's have the last step, and let me just think it over if we can. So we got like machine learning, we got zero knowledge, we can verify on the blockchain. We have an idea as well how we can use it, but let me just start brainstorming on tokenizing this whole stuff. So why is a good thing doing tokenization in blockchain? So tokenization has a pretty interesting property from an economic sense. It has kind of a cryptographic ownership. So I would say that's kind of an ownership, which is not legal, not physical, but I would say cryptographic. So, and usually you can even trade this ownership. So if you have like characteristics in economic, which is like ownership and trading of ownership, then usually you have like improved markets, more markets, more transparent markets, a lot of market dynamics, of course, both in a positive and of course in a negative sense as well, like having bubbles and so on and so forth. That's all like the idea is that you have like an ownership. You can just own in a sense an asset which previously wasn't exist, I would say, or you couldn't just own this ownership. Couldn't just own this asset. So what are the possibilities of tokenizing zkML? Well, like one idea is like you can have something which is so let me think that we have like a kind of a machine learning algorithm, and we just want to keep secret, but basically it should be used somehow, or it could be used on chain somehow, and then we just want to have like a service. We just want to create zero knowledge proof as kind of a service level agreement for our machine learning algorithm, and we just want to create like an intellectual property right for that, which is tradable. Then actually a token is like a great way of doing something similar. That's one idea. The other idea, which is more hyped at the moment, that's like we get kind of a generated data. And this is a hot topic of, especially if you think of like AI generated content or AI generated digital art. So the question is, let's just imagine that we have like an NFT, and then basically that NFT was somehow generated by an AI, by a machine learning algorithm, and we just want to create basically a token and ownership for that data, which is a piece of digital art, and we just want somehow represent in an NFT form. So that's the second idea, which is more hyped. And then for the second idea, there's already one standard, which is the ERC 77 or 7007 token standard, which tries to capture somehow this last mentioned property, which is like, again, so that's going to be a standard for AI generated NFT. Okay, and then if you think of AI, we usually think of like kind of a zero knowledge proof hardened machine learning algorithm. But of course, I mean, it's just more general here, like saying AI. So what we have here is like we just want to combine somehow AI generated content with like a classical NFT standard that's ERC 721. So what we want to do, basically, we just want to prove practically an ownership and the token if certain NFT was generated by a certain machine learning model and input, basically. So somehow the idea is that I have a great prompt. I mean, if it's like more like ChatGPT, then we don't use like input, it's just a prompt. But I just figured out a great prompt or a great input. I just have like a great machine learning model, or somebody has like a great machine learning model, and I just generated a top NFT, basically, which is a piece of digital art. But it's kind of an AI generated NFT, AI generated tokens, so it's like a little bit more tricky. So I just want to prove in a zero knowledge sense or in a snark sense that basically I have like an input, and then the output, which is like the digital art of the NFT, was generated by the machine learning model. So that's the idea basically of the ERC 7007 token standard. So it usually looks that way. There's the user claims an input, practically publishes the hash, and then basically there's like a zero knowledge proof that is generated that the output is based on the input and the trained machine learning model. And so again, that's just like an inference, basically. And the verifier can verify that the output and the hash of the input and the zk proof is valid. And if that's true, that basically the verifier, which is like the smart contract itself, will basically know that that input is the basis of the output, basically, which is a piece of digital art, and we can have like an NFT token based on that. Okay, and so at a successful verification, the user will practically own the input. It's just a little bit more in details, but I'm just gonna take a look on the contracts itself just in a second, or just some demo. There's like a token standard, and there's already some proposed implementation as well for that standard. So basically, it has like the properties of machine learning model. There's like a zero knowledge machine learning prover, and there's a smart contract, of course, and basically there's a verification phase as well. Here we get like a different contract for verification. It's because I mean, if you usually like use a zk framework like zkML, it generates for your verification contract. So basically, that's why you might well have it in a different contract, but usually you can have the verification basically in your same NFT contract as well. So the idea is that like the user or the user has like an input, which is like a prompt for a machine learning algorithm to generate like a very great digital piece of digital art. And then basically this input, this prompt is an input for a machine learning model. And then that produces some very nice output, and there must be like a zero knowledge proof on that this input was really the basis basically of that very beautiful output. And then that must be proven and then verified. And if there's a verification for that, then there can be a new NFT minted, which has like parameters like the input and the machine learning model and the proof as well. So basically, in a sense, the customer or the user just owns this input and the generated model. So basically, this AI generated art. So let me have some demo. I just wanted to implement my own token basically, but for the time being, it just wasn't very much possible. So let me have if I can just I just use a couple of demo. I have one demo here. It's again not mine, unfortunately, due to time constraint. I just couldn't build up my own system for this demonstration. And this is like a demonstration for a zero-knowledge machine learning. It uses this MNIST. Basically, MNIST is like numbers. It's a sample for numbers or a sample set for numbers. And as far as I know, this demonstration uses a convolutional neural network for verification for zero-knowledge proofs. And then, convolutional neural network for machine learning, and it uses Grow16 in zkML for zero-knowledge proofs. So practically, this is my input. So I just draw a digit, which is like, I don't know, 5. If I'm a image, I just say classify and prove. And if that works, it just takes time. So what I'm gonna have here, and based on my input, I have an output as well, which is 3 at the moment. So I mean, it can be seen that it's just not perfect. This convolutional neural network wasn't trained very precisely. But anyways, there's an output. This is my output. This is my input, or we can say this is my prompt in a prompt engineering sense, and this is my output. And there's basically actually a zero-knowledge proof on that in Grow16, which states that it's perhaps just a snark, but it states that based on this input and the parameters of the convolutional neural network, there was a calculation which had the output of 3. And as far as I know, the input is not even zero knowledge, but it might be zero knowledge as well. So we can just have some new, so it's just say 8. Hopefully it works. Then we're gonna have like an inference, which is an output, which gonna be hopefully 8, but I'm not sure. And there will be like a zero knowledge proof on that as well. It just takes a little time. So I mean, the prediction is correct, which is a good thing. And then here's basically a zero knowledge proof on that as well. Okay, so this is like the zero knowledge proof part. And then if you just take a look on the token part, that's like the ERC 7007 token. It looks that way. That basically doesn't say much. It just has like 2 functions and then 1 event basically. One function is like add artificial intelligence generated data, which has like the token ID, practically the prompt, which is the input, that's the output more or less. That's the artificial AI generated data, and then there's a proof, and there's a verification as well. which again has like a prompt, the data and the proof as well. Perhaps it's important to point out that this token standard works both for zkML, zero-knowledge machine learning, and for optimistic machine learning as well. So there are some optional extensions, but if we just take a look on the metadata, which is again the basis is like an ERC 721 token standard, so it has some metadata property. So we can see in the metadata, like for instance, there's our input somewhere, that's our input, that's our prompt. Then we got the AI generated data, and we got, for instance, the proof type as well. And the proof type can be both zkML or optimistic machine learning as well. So that's the token standard, but we're gonna have some experimental implementations as well. So this is how an experimental implementation looks. It looks that way, but again, we just have like this couple of core algorithms. So we got a mint basically, and then the mint looks that way, that if you say like you have like an input, I just don't need this. So you have like an input, and you get like basically the AI generated data, and you get the proof. And then I think your machine learning models should be somewhere committed previously, but then basically either you get a token ID based on some magic, so like hashing together all the data, or you can even claim a machine ID, a token ID for that. But if that happens, basically what you have is that you have somewhere an ad which has like a verification part. So in the verification part, there's basically a zero-knowledge or a snark verification, which verifies that the input and the output and the proof was basically valid practically. And then this verification part is usually a different smart contract, which is like generated by for instance, by the zkML framework, and it might contain actually all of the public parameters, or all of the committed parameters, or all of the keys of your proving systems. Okay, so that's the idea for an ARC 7007 token standard. So basically that was my demo, but anyway, the presentation was taking longer than expected anyway. So in conclusion, I would say AI and blockchain mixed applications, that's a very interesting topic. But and of course, I mean both fields are overhyped. That's not a question, but that's how IT looks today, basically. And I would say there's very few very good like decentralized AI or decentralized blockchain application. And I would say the reason is for that because up to this point there was a missing point, and this missing point was like either having AI or machine learning calculation on chain, which is still not really possible due to scalability issues, or bringing off-chain calculations in a trusted way on chain. And I would say the ZK stack, zero-knowledge stack, is getting to be ready for having this merging of field. So there might be very interesting application areas in the futures again, and tokenization just accelerates everything in an economical sense, because as soon as it's tokenized, you can trade, you can pay for that, you can just make token sales. So basically just boost economics as well. So I'm sure we're gonna see a lot of nice applications. One big application area is like DeFi. I mean, as we have like tokenization behind, basically most of these DApps, decentralized apps, are based on tokens anyway. So if you just have like one special token for imported zero-knowledge machine learning results, then again, it can be very good integrated probably with DApps. So I'm sure we're gonna see a lot of interesting applications in the future. So that was my presentation. And again, it was taking longer than I expected. So I would say I would just stop here. I don't have more demos or slides. So if there's any questions, comments, or I don't know, ideas, discussion, I'm happy to try to answer, discuss, or comment, or yeah, anything. So I'm just browsing actually the chat. But if you have any questions, just feel free, unmute yourself and ask, or you can just drop basically in the chat as well. So yeah, like one idea is like the provenance of the large language models. I mean, these ideas were firstly applied for like the classical machine learning stack. So it's like, again, like classical neural network, which is like trained by like a backpropagation algorithm or in an unsupervised manner. But it's a very interesting merging possibility to have like large language models basically integrated. Of course. I mean, the question is it large language models? So the problem is that like making a proof or creating a proof, a zero-knowledge proof, actually has some computational limitations as well. I mean, if you verify the proof, that's usually fast, but creating a proof is not always the fastest way. So if your large language model is very, very, very big, it might happen that the capabilities of calculating that snark proof is still limited. But I would say that's gonna evolve in the future because I mean the zero calculation speed actually, I don't know, accelerates each year pretty heavily. So there might be the possibility in the future to have like really big like large language models and integrated here. Verifiable credentials for large language model application, node authentication. It's a good question how we can combine like verifiable credentials. How can we brought verifiable credentials into the picture? It's a good point. I'm not so sure at the moment, but yeah, I mean, if you just think of like zkML, you can basically, that's like almost like a cryptographic primitive that can be integrated either with blockchain or with like a classical or not classical, but like a less blockchain oriented verifiable credential system as well. I just don't see the application areas as well, but again, technologically, I think it's possible and it might raise some very, very interesting application areas as well.
I have a question. First of all, thank you, Danielle, for the presentation. It was very interesting. And I just had a hard time. Sorry.
Sorry to interrupt you. Actually, I have 3 questions. Can I ask?
I think I was okay. Go ahead.
Yeah.
Sure.
So let
Sorry. First, you should ask.
Okay. I'm having a hard time understanding what's the exact benefit of using machine learning is in these types of scenarios. Like, what if we use a deterministic algorithm that gives us, I guess, deterministic results? Like, what's the use of machine learning exactly in these processes?
Yeah, so the idea of machine learning, it might be deterministic, I would say. It's like, you have a bunch of data, like, I don't know, like hundred thousands of salary information of different people. And then you just want to create a credit scoring, for instance, okay? And then you do it in a way, you train a model basically based on this 10,000 data, which is like a neural network, with a backpropagation algorithm, and you just train this model, okay? And then you have your trained model, which evaluates a credit scoring, and you just want to import this credit scoring trained model into the blockchain, but you want to do it in a trustless way. And if you want to do it in a trustless way, so I mean, let me just have some sketch somewhere. So again, so the idea is something similar. We get a lot of data. That's like people and salary and risk and stuff like that. Okay, so that's like data. That's data. And we want to train basically a credit scoring algorithm, which is like kind of a neural network. I'm not quite sure if I manage a great neural network, but like this one is like kind of a neural network. Okay. So I just train somehow. And it gives me basically a credit scoring. So again, that's a lot of data on people having like age and salary and geographic location and stuff like that. That's the input, and the output is like high credit scoring or low credit scoring or medium credit scoring. Okay. But the problem is that this machine learning model is centralized. So you want to bring the result somehow on chain to the blockchain, because that's my blockchain, because we have like, for instance, a DeFi application, and the DeFi application wants to use basically kind of a result of a credit scoring algorithm. Okay, so that's like a neural network which gives like a credit scoring. So the question is, so that's like output. So how can we bring like the result of this trained neural network, which is a credit scoring algorithm, on chain to the blockchain, to our DeFi protocol in a trustless way? And there are 3 ways of doing it. I mean, for the first round, one way, we just bring this trained model and then we implement everything in smart contracts, and we just run this model in smart contracts. And then we have our credit scoring model on chain. Everything is decentralized, everything is fine. But the problem is that this model might be pretty big, even computationally, even the inference phase. So basically, running everything on chain might not be the best idea. We got some scalability issues with most of the blockchain systems. So what we need to do, we just need somehow to run this neural network, this trained neural network, which is a credit scoring algorithm off chain, somehow in a centralized way. But basically, as this is a decentralized application, or this is a DeFi protocol, we just want to import the result of that credit scoring algorithm, which is a neural network, which is a trained neural network, in a trustless way. And what we can do, we have like 2 ideas. One is like using optimistic machine learning, and the second idea is like using zero knowledge machine learning for that. So that's the whole story with like a little bit more pictures. I don't.
I got it. Thank you.
Did I manage to answer your question?
Yes, it's very clear. Thank you very much.
What there was somebody asking some more questions, if I'm not mistaken.
I didn't decide, Muhammad Ali.
Yeah, sure. I mean, just go ahead.
Yeah. Actually, I am a recent university pass out student. So actually, I want to ask that what are the entry rules are available for someone fresh out of the university for the zkML or a blockchain space?
So I'm not so sure. There's like a university. I mean, I'm sure
No,
there's like
actually,
a lot of research on this topic, but I'm not quite sure which university has like research and
no. Actually, I am saying that I'm a recent pass out student, so that I want to do a job. I am asking that what are the uh, entry roles for me in this
okay, okay.
field?
Yeah, that's a good question. Honestly, I'm not so sure. So probably so this is like a more advanced topic. If you want to deal with this, especially, I mean, absolutely with this topic, it's probably for the first round research and development. So I would propose to have
Yeah.
like university research, and there might be some protocols that already have like publish a couple of papers, and there might be like protocols like I don't know, perhaps Ocean Protocol, and like a few, like a half dozen protocol that might already consider zero knowledge proof with the blockchain and building up like ERC 7007 tokens. So again, it's this whole field is pretty much in research and development. So either you target directly, that's half dozen of protocols that are already experimenting with the technology, or you just create a couple of like you know, scientific papers, and then that's like a good reference. But perhaps if you're an entry level, professional, it might not be the best idea to start the first engineering job basically with zero knowledge machine learning.
Mhm.
Again, that's very much research and development oriented. So if you're good in research and development, absolutely. But if you happen to be not, your primary idea to deep dive in research, then I would say like a simple, I mean, Solidity programming or Hyperledger Fabric programming. That's like more, classical like engineering jobs overall. Again, if you want to deal exactly with this topic, my suggestion would be like you can find a couple of good references. Basically, I will just publish my slideshow after the presentation. You will find a couple of references and research papers as well. But probably the best idea is to write one or two research papers and then target that like half dozens of protocols that already experimenting with the technology.
Yeah, sure, understood. Actually, I have one more question as a personal question. Can I ask?
Yeah, sure.
Actually, I want to ask that I want to start my startup on the healthcare sector. I want to build something that for analyzing the disease and for solution for that, like Parkinson's disease. So, can I use this zero knowledge proof technology for the Parkinson's disease or something else for my startup?
It's a good question. I'm not sure if I have like a yes or no answer. So I would ask the first question. Do you want to use machine learning for analyzing the Parkinson disease?
Yeah,
That would be my first question, because you might not use machine learning at all. You might not use AI at all. So if you use machine learning and you get like trained machine learning models, then the second question is, do you need blockchain for that? And if you need both machine learning and you need to verify your machine learning result on chain, on the blockchain, then yes, then you can use this approach. Otherwise, it's just more tricky. So if there's no need, then I wouldn't use this approach because it's pretty tech heavy. Just one comment, basically. I mean, especially like the healthcare applications. If you have healthcare application, and if you have machine learning, and if you need the blockchain as well, then usually you should use either the private input public model or even the private input private model scenarios. It's because everything which is in healthcare is private. I mean, your model might not be private, but certainly your input, the prompt that's gonna be private. It's because all healthcare information is very much private. So basically, that's like a good approach, or that might be a good approach to use for your private input, really a zero knowledge proof, in which you just need the zero knowledge property. But again, that was just general answer. I'm not a healthcare professional, unfortunately. Again, these are the two things that you need. You need machine learning and you need a blockchain. I mean, you need it in a meaningful way. And if you have, then you can consider the approach. Yeah.
Yeah, sure. Thank you so much. Actually, you are an experienced person that's why I'm asked the questions. So thank you so much for answering the questions. I really appreciate it.
You're welcome. So if you have any questions, just go ahead and unmute yourself and ask it. Otherwise, I'm just browsing the chat. So if I see like questions that I can answer, then I'm just giving a shot. So there's a question: what problem do we intend to solve by using AI in the zero knowledge function instead of the current way? So we don't use AI. We don't use AI in the zero knowledge function. We use AI in a way that it's off chain. So this can be like an AI as well. And we just put a zk proof. So we just put here plus a zk, and then we just make sure that with this zk or snark proof, everything which is on chain will be off chain. Sorry, so off chain will be imported on chain in a trustless way. So it's just the little bit the other direction. So what are the benefits of NFT over verifiable credential in this use case? I wasn't evaluating that very strongly. Again, I'm not so sure if there's already initiative for using zkML with verifiable credential, but it's a very important, it's a very interesting approach. It's a very it can be a very interesting initiative. I would certainly brainstorm on that. Generally, I can answer what's the difference between NFT and verifiable credential in an application point of view, from an application point of view. So we usually use NFT if something should be traded and transferred. So if that's like a token that should be traded and transferred, that's like more NFT, more like an NFT. With verifiable credential, it's like a piece of paper that is issued in a digitized form, like a diploma, for instance. And then usually you don't trade with your diploma. You can like have it reissued, for instance, but usually you don't trade with your verifiable credential. That's the difference between NFT and verifiable credentials. So I usually suggest the idea that, you know, if you have like something which is so if there's like a question if I should prefer an NFT over verifiable credential or vice versa, I would say if trading sorry, and transferring ownership play a very important role, then I would use NFT. If that's more like, you know, a piece of digital document, which is like a diploma, then it's more like a verifiable credential. So there's question like how we can develop product like GTP in blockchain. It's actually, I'm not so sure. I'm not quite sure what's ski machine learning. Uh, Yeah, sure. So what I wanted to, I'm just browsing a little bit the chat and brainstorming if I can answer the question. There's a recording. You will find the recording in the YouTube channel of Hyperledger. I will share basically the slides as well, and it's gonna be under the Hyperledger channel as well as a comment. And basically, you will find in the meetup itself, and you might as well get it in email as well from David. So you will get everything basically, and then there are a couple of good links in my slideshow as well. What I wanted to say, for instance, it's like there's even a couple of like scientific paper as well linked, for instance. So if you just want to research basically on the topic yourself, that might be a good start as well. And you will find basically all the demos as well. Again, they weren't implemented, unfortunately, by me, but perhaps next time. I'm just showing one big question. I'm just trying to understand it. Yeah, there's a big question. If you can put the model on chain. So usually what you can have, you can usually commit. So this is like your model, and it has like a lot of parameters, like I don't know, like these are the P parameters and P, like a lot of parameters. And what you can basically do, I mean, you can even publish your whole model on chain, but what you basically do is that you can commit your model on chain. So you say that you just hash basically all the parameters of these models, and these are the parameters of your models, and you can commit your blockchain your machine learning model parameters on chain. And then the zero knowledge proof might contain a proof as well that the committed parameters was used as well. So that's like one idea. And there's a hash commitment, usually which commits either the parameters or the input, and then it means basically that your input is not visible or your parameters are not visible because only the hash is there. But in the zero knowledge proof, there's a proof for that based on these parameters or based on this input was basically the whole evaluation executed. Yeah. Yeah, I'm not quite sure if how you can do like GPT in blockchain. Again, so the idea is that probably not GTP in blockchain, but like, having like kind of algorithm off chain and then importing the result on chain. That might be the direction for the first run. I would say it's a little bit tricky. So if you like use like large language models, then this computational phase might be tricky. So basically, you just have probably like large zk proofs, which might be, I mean, the generation phase of such zk proof might require some very heavy computation at the moment. So it might not be feasible at the moment. Perhaps just in a couple of years, or you need like an extreme resource for generating that zk proof. I wouldn't go very much. There's questions on verifiable credentials, but I wouldn't go very deep into the details. It's just basically verifiable credential is like a diploma. If you have a degree at a university and then you just get a paper which is like a certification, which is like a diploma that you get a diploma from that university, that's like a verification verifiable credential, or that can be represented by verification credentials. And then verifiable credential might not require blockchain. You can have a blockchain component that ensures practically data integrity and signer identity. So like you got your diploma, which is like which is a digital document, which is a verifiable credential, and then you can have it basically in identity wallets. So you don't necessarily need a blockchain for that, but usually the system is hardened a little bit like with an identity blockchain, which contains like the data integrity information, so like the hash of your verifiable credential or your diploma, and it contains as well like the some identity information as well, or some pieces of identity information, especially like if you get the university and then the university signed that document for you, then the blockchain is basically a private registry as well, containing like the public key of your university. So basically everybody just can read out that, hey, this signature is really from that university. That's like identity blockchain. But again, you just don't necessarily need like blockchain for verifiable credential systems. There are a couple of good meetups on verifiable credentials, self-sovereign identity, and blockchain as well. Some high level from me as well, but there's a lot of like Hyperledger. So if you're interested in like that's Hyperledger, and then Hyperledger is basically like an umbrella project, or slowly we can say like Linux decentralized trust. So there are many projects, and there are a few projects that focus really on blockchain, and there are projects that focus more on on the decentralized identity and verifiable credential and self-sovereign identity and identity blockchain stack. So if we just take a look basically somewhere, not quite sure if I have the projects, but anyway, it's that project overview. So like Iris is like identity stack. It's like Indy is like identity stack, all projects that I have. And then you have like couple of labs as well. Identus, that's like identity stack. Iris is identity stack. Indy is identity stack. And then I would say Anoncrats, that's an identity stack project as well. So there are many projects, and I would say blockchain and identity, or identity Vitor, decentralized identity Vitor blockchain. That's a very big topic, and there's a lot of good basically recordings and meetups and stuffs like that. And it really has like couple of different projects already. So I would say we are slowly running out of time. So if there's like, I don't know, like 2 more questions, then perhaps I'm gonna take a shot and just try to answer them. So if there's no more question, then I would say thank you very much for the participation and for the attention. That was the meetup today on a pretty niche topic. But again, I would say that's a very interesting topic, and it might be very significant very soon, basically. So that was the meetup for today. So thanks for your attention, and then see you next time.